Okay, so in this video, I'm going to show you guys how to graph an exponential equation or an exponential function, sorry, much faster than what we did in class. So in class, what we did, we kind of used a table function, but here's a quicker way to go ahead and graph these. So if you want, just go ahead and write this down, and you can pause the video meanwhile, and then we can go ahead and do an example, because I'm going to do an example right now. So before I get to that, here in this first portion, right, we have exponential growth, right? So basically, if the value of a, where a is just a number that's being, like the base, right? If the number is greater than 1, then the graph is going to look like that. It's going to be exponential growth. It's going to go through this point 0, 1, and it's going to have a horizontal asymptote here. So for example, the function f of x equals 2x to the power of x is going to look like that. However, if the number is between 0 and 1, right? So then in that case, we're going to have exponential decay. So it's going to be going down. It's going to go through 0, 1, and you're going to have this horizontal asymptote. So for example, I put here 0.5 to the power of x is going to have that. So this is basically what we have. Now, if I were to have an h or a number right next to the x, right? In this case, there's nothing here. If I were to have a number here, then I'm going to move the graph h units opposite of whatever this sign is. So if this is negative, I'm going to move it to the positive direction. So I'm going to move it to the right. Kind of similar how we did it with the vertex form. Now this k, I'm going to move it up or down depending on what k is. So I'm going to do an example. So let's say I had my function to be 3 to the power of x minus 1. So let's say we have something that looked like that. So how would you go ahead and graph that? So the first thing that you kind of want to know is this going to be exponentially increasing or exponentially decreasing? Well, you know that it's going to be growth because this 3 is greater than 1, so the graph is going to look like that. So the graph of this is going to still look like this. So it's going to go right through this point, right? It's probably going to be a little bit more steeper because, oops, I messed this up, but whatever. So it's going to look like that. Now you can use your table function to put more points, but I think the first thing that you want to be able to do is be able to graph this, okay? Now we're not done because this is a graph of 3 to the power of x. Now we have an extra x minus 1, right? Now what does this mean? I'm going to move it to the opposite direction. So I'm not going to move it to the negative side, I'm going to move it to the positive side. So this one, I'm going to move it 1 unit to the right. Okay, so now I'm going to move it here. Okay, now my asymptote, I'm also going to move, but did it look like I really did anything? If I shift it over to the right, it doesn't really do anything. It still stays there. Okay, so two things that you want to be keep in mind of: make sure that you move the y-intercept and also the asymptote. So when I graph it, it's going to look something that looks like this. And my red graph is the graph that I want. That is my graph of f of x. Okay, that is my graph. Okay, do you need to know any other points? Well, you can try to figure out what the point of this is, right, using your calculator. But all I care is that you shift the asymptote and that you shift the y-intercept. Okay, all right, let's do another problem. So let's say I have instead f of x equals, I don't know, 0.3 to the power of x plus 1, and then let's do a minus 2 here. Okay, so let's say we have something that looks like that. Okay, so first things first, let's go ahead and graph it, right? Now, we know that it's always going to go through 0, 1, okay? It's always going to go through there. Now, the first thing that I want to do is this going to be exponential growth or exponential decay? Well, it's going to be decay, right? Because if we look at the base, 0.3, this number is a number between 0 and 1, right? So it's going to be decaying. So it's going to be going down like this, okay? Now my asymptote's still right there, okay? Now let's go ahead and shift it. Now that I know that it's going down, okay? Plus 1, okay, so what does this plus 1 mean? I'm going to move it the opposite sign, right? So I'm going to move it 1 unit now to the left. Okay, so 1 unit to the left now. Okay, so now my graph, when I move it 1 unit to the left, looks like this. Okay, And then my asymptote, when I move 1 unit to the left, well, it doesn't really do anything, right? So it's still there. Okay. Okay, but I'm not done yet, right? Because now I have to work with this -2. So now I got to move it -2 units. So I'm now, this negative says that I'm going to move it 2 units down. So right now, looking at the blue graph, right, I'm going to move it 2 units down. So right now I'm at 1. I'm going to move it 1 unit down, 1, and then 1 more unit down at -1. Okay, so now my y-intercept is now there. Now, what else do I also got to move, though? I also have to move the asymptote. Whereas the asymptote didn't move when I shifted it left and right, it will move when I shift it down, right? So this asymptote is going to go down 1, down 2 units. So now I'm at -2. So now my asymptote is going to be at -2. All right? And now remember, it's the line that I cannot cross, right? So my graph is going to look something like this after I shifted it. Okay, so notice that the movement between the black curve to the blue curve was just shifting it +1 unit, which is in the opposite direction, right? And the movement from the blue curve to the purple curve was -2 units because of this thing, right? Okay, so this is the purple curve is actually my answer. This is my answer. If you want to be if you want to plot more points, you can, but all I really care about right now is just the asymptote and just the y-intercept. Now, just for funsies, right? What is the domain and what is the range? Because you will have to do this for your take-home exam. Remember, the domain for all exponential functions is always going to be all real numbers. So it's always going to be -infinity to +infinity. Now, what about the range? Well, where does the y value start? What is the lowest y value? Well, the lowest y value is at the negative and the -2, right? That's where the asymptote starts. So it's at -2. Is -2 included? No, because asymptotes are not included. And then where does it go up? It goes all the way up to a +infinity. Okay, that is where my domain and range is. Okay. Do you guys want to try another one? I don't know. Let's see. Let's just do one more. Let's say I had f of x equals e to the x minus, no, let's do +3. Okay, so how would you graph that one? Well, same thing, right? The first thing that we want to make sure is that, well, we know that the asymptote is always going to be at y equals 0. This is going to go through 1, 0, 1, right? Now, is it going to be increasing or decreasing? Well, let's look at the base. The base is e. What is e? Well, remember that e was just approximately equal to 2.71, right? It was just a number, right? Now, 2.71 is a number greater than 1, so it's going to be growing. Okay, so it's going to look something like this. Okay, that's what e is going to look like. Okay, now we don't want just e, right? Now let's go ahead and shift it. We're not moving anything to the left and the right now. Now what we're doing, we're moving it up 3 units, right? This means move everything up 3 units. So starting with the y-intercept, move this 1, 2, 3. So now I'm at 4. All right. Now with my asymptote, I'm going to move this asymptote up 3 units. 1, 2, 3. Okay, so now I'm right here. Okay, and all we got to do is just graph it. Make sure that it doesn't go past it, okay? If you wanted to do domain and range, remember domain is still all real numbers, right? From -infinity to +infinity. What about the range? My range in this case, well, where does the graph start? The brown graph, it starts now at 3, right? Because that's where the asymptote starts, at 3, and then it goes all the way to infinity. Okay, so there you go.